And so you're like, hey, API, give me the data from my widgets, and then I render it. So it's sort of an imperative step, kind of like manually telling the client tells the server, give me that thing. Where sync engines, it's a move from imperative to declarative. So instead of saying, give me that data, it's sort of like, for this page, I declare I need this data. And then the sync engine makes it so. You often run into the problem where you're like, just like sort of getting data is easy, but subscribing to updates is hard.
Welcome to the Local First FM podcast. I'm your host, Johannes Schickling, and I'm a web developer, a startup founder, and love the craft of software engineering. For the past few years, I've been on a journey to build a modern, high-quality music app using web technologies. And in doing so, I've been falling down the rabbit hole of local first software. This podcast is your invitation to join me on that journey. In today's episode, I'm speaking to Kyle Mathews, who's in the past has been the founder of Gatsby JS and is now exploring local first software. In our conversation, Kyle shares his experience building some small-scale local first apps for his personal use, and how using a data syncing engine frees up a lot of his development time. Before getting started, also a big thank you to Expo and Crab Nebula for supporting this podcast. And now, my interview with Kyle. Hey Kyle, welcome to the show. How are you doing?
Doing great. Glad to be here.
Thank you so much for coming on. You're another fellow early local firster, so I'm very curious to hear about your background and then hear about what led you to local first.
So I've been doing web development of various sorts for like the last 15 plus years. Seen a lot along that way, like the whole jQuery era, did Backbone JS for those who read history books, and it was early React, GraphQL. I actually started with Drupal. Funny fact, Drupal was big back in 2000, still widely used, but people are like a little more expansive about their view of Drupal back then. Then switched to kind of JavaScript single page apps like really early 2010-ish. And I've been kind of writing that ever since. Yeah, then of course, Gatsby 2015 introduced that, which kind of like took React and was sort of the first proper production ready, React meta framework. And so kind of rode the whole React wave for a long time. But yeah, in general, my interest is what are the tools we use to build software? Because like I think software is very important, and the quality of the tools that we use determine the quality of the software that results. We shape our abilities, and our abilities shape us. So sort of like we shape our tools, and then the tools shape everything else. Because I think there's really like high leverage to kind of continually pondering that question. Because if we can genuinely move to a genuinely better tool, then there's enormous effects that result from that. Not just in our actual day-to-day life, but like, we're as software creators, like there's a lot of people whose lives are affected by software. So yeah, I've seen like genuinely better tools emerge in sort of my software career. So like, I think React was a massive step forward. I think GraphQL was a smaller step forward, but also a genuine step forward. And I feel like, local first, it feels like this is another sort of massive leap forward in how we build software. And I think it's something that in the coming years, more and more software will be kind of built in this fashion.
I definitely agree. I mean, I'm also definitely a connoisseur of good tools, but luckily there's a lot of good tools in many different areas of development overall. Like you can also look at other language ecosystems. I'm definitely very interested and inspired by all the good stuff that's happening in the Rust ecosystem, but also super cool ideas that you find in other ecosystems, such as like the Elixir ecosystem with live views, etc. So there's like a lot of great tools and great ideas in all of those places. But I'm curious, which sort of problems have you experienced in the past that has led you to local first in particular, and where you now see a different approach how to deal with those with local first?
You could sort of think of like client server development. There's sort of three problems. There's sort of the UI, like how do we construct the UI? How do we do interactivity, charting stuff? So there's a lot of like different areas within like the UI. And then there's sort of backend problems. There's a lot of like complicated computing bits. There's like, how do you run infrastructure at scale? How do you make things efficient so you're not like, spending enormous amounts of money, security. There's endless domains of problems in the backend. And then there's kind of like the middle bits, which is like state transfer. Like, how do you move bytes back and forth? Because generally the client can't hold all the data. So you have to like say, I need part of the data to be pulled over. And like generally things are changing. So like how do you get that data from the server to the client and so on. And so there's a lot of problems around moving state back and forth. And so yeah, so I think Local First is interesting because I feel like the front end and the back end, there's been just enormous number of innovations in both sides. All the investment in React and Svelte and Solid and Vue and like Vite and Webpack, and there's just like enormous investment that's gone into making the front end experience dramatically better. Plus all the all the libraries. There's like NPM has like millions of libraries or something like that. I don't know. Like each of those things is just like enormous effort from individuals and groups all across the world, and it's made the UI world dramatically better place. Like it's just remarkable to me how much faster it is to build amazing stuff versus like 15 years ago. Like the first like big JavaScript dashboard I built, it took me like 6 months to ship the first version. Partly because I wasn't a very good programmer, but partly because like there was just like no guidance anywhere. Now there's just like endless starters, endless use cases. Like React is such a compact, simple abstraction. It's dramatically better. And that's because there's been like tons of innovation there. In the back end too, there's like all the cloud giants are pouring tons of research into stuff. And there's like tons of individual cloud services where before you're like, hey, that's 3 months of programming. And now it's like 2 hours to implement an API and off you go. So there's been lots of innovations too in the back end. But yeah, the state transfer bit, like the, moving bits back and forth hasn't really, I don't know, got as much investment. Partly, I think it's like, it's not always a problem. Often it's pretty simple. If you're just sort of like building a dashboard, you're like, get me the data for the dashboard, render the data. It's not a very complicated problem oftentimes. But I think what we're seeing is that we're like the best teams, the best apps investing disproportionately their time compared to everyone else. Because that's kind of where the best teams see a kind of an advantage that they can like build something significantly better than other people. And so what I think you're seeing now is like the best apps in the industry, like the Figmas, the Linears, Superhumans, etc. They're pointing now towards sort of state transfer. Like, how do you load your app extremely fast because everything's cached locally? How do you have real-time sync between, different people so you can build like rich collaborative experiences? How do you, save locally and then sync backwards so you're not like doing little spinners all the time when you save stuff, so it's like always fluid and fast. And they're all kind of arriving at the same idea, which is like, hey, this whole like REST, like posting things back and forth, pushing bytes around manually doesn't cut it anymore. To build like really complicated, amazing apps, you need a higher abstraction. You need something more sophisticated for handling that state transfer. And that's sort of like this local first and or like sync engines is kind of like the component that sort of handles that state transfer back and forth between the client and server.
That's super interesting. So you mentioning the term sync engine, that might be not familiar with everyone in the audience. So could you elaborate a little bit what a sync engine is and how that might relate to the approaches that you've mentioned before?
I feel like it's the best term for uniting a bunch of different tools and their approaches. But yeah, the basic idea is that REST API, GraphQL API, TRPC, whatever, they're all based around rendering a page for widgets. It's a widget page. And so you're like, hey, API, give me the data from my widgets, and then I render it. So it's sort of an imperative step, kind of like manually telling the client tells the server, give me that thing. Where sync engines, it's a move from imperative to declarative. So instead of saying, give me that data, it's sort of like, for this page, I declare I need this data. And then the sync engine makes it so. And you often run into the problem where you're like, just like sort of getting data is easy, but subscribing to updates is hard. Like everyone kind of notices there's a massive gulf in difficulty between those two things. And so what's cool about sync engines is that because it's sort of more of a declarative step, there's actually no additional complexity to get subscription. This guy is the same thing. You're just saying, I need this data, and then the data shows up. It's a new abstraction for how data arrives on the client, where, again, you're going from imperative to just being like, you're describing the shape of data that you need to show up on your site for a particular page. Another good analogy, it's very similar to the shift from like jQuery to React, where jQuery, you're like, get this DOM element and tweak the text. or get this DOM element, remove the child, construct two other children, plop it in. You're like a little kid playing with like blocks or something. You're like, and you're like fiddling all the time, which was actually fun. I actually enjoyed it. It was a fun little challenge, but it's a huge waste of time. Where, we moved to React, and React is more like, I don't know, I want it to look like this, and just sort of happens somehow. Like React does a bunch of weird magic under the hood, and it just kind of efficiently somehow shifts everything around without tearing, and voila, it's there. And you're like, cool, it's there. And yeah, that's just a lot less to think about when you're just like, I want something to be so, and I don't really care about the complicated details. That's a lot less to think about, which is the value of abstraction, because we have a finite amount of things we can think about. So if we drop two, then we can like replace it with two other stuff instead. So if you drop a lot of thinking about state transfer, then you have more time to think about other things.
So you've now explained a little bit the benefits of a sync engine and that it simplifies a lot of things. But for someone who's now like curious, how does this actually work? Can you explain what a sync engine does and how it does it?
I'll use an example for the one that I've used the most, ElectricSQL. So ElectricSQL is sort of Postgres based, and you have your tables, and basically the shape is like kind of declared like, this is the shape of data I want pulled over. It's just like a SQL query. So you're just like, I want this table and rows that match this criteria. And then the sync engine kind of like takes that and then it says like, okay, I will send you sort of the initial bunch, and then any updates that I see from then on that match that shape, off it goes.
That makes sense. So, and this would be one particular example, one particular technology for when your starting point is an existing Postgres database. So, is that the way how I should think about it? That like I have my like traditional way of how I'm dealing with data in a more global state, for example, Postgres, and then I'll just slap a sync engine on top of it, connect my clients to it, and off I go.
In theory, in practice, all these tools are like, this whole space is pretty new still. So I think that's sort of the platonic ideal that everyone's working towards, is like you just sort of slap a sync engine on and off you go. And that does work in some parts. All these tools are like, there's some limitations that you have to kind of live with, and that they're working to lift, but there's understandably a decent bit of complexity to kind of like take this 30-year-old, whatever old Postgres is, technology, and toss a new thing onto it. As long as you live within the abstraction, like kind of, or live within sort of the existing limitations, then yes, that is actually the very, very much the reality. I've been building like a number of sort of toy stuff, both to play with this local first approach, sync engine approach, but also, exploring a number of other things. And it is like very simple. You just say like new table, and then it creates a client side library, kind of like very Prisma-esque. Actually, they're still using, I think, Prisma under the hood to generate the client. And then you just immediately just start reading and writing from like the local SQLite. So because they use Postgres in the backend and then SQLite in the client. It's very straightforward. You just like write a query and data's there. Do an insert, off it goes. So I can't promise it'll work for like, yeah, anything will just work. But if you're living within sort of the current restriction, it is very much a magical experience.
That sounds great. And I think there's a lot of different approaches how a sync system could work. We've also learned a bit about auto merge in previous episodes. But I'm curious to hear more about your experiences building apps with the stack that you've mentioned. Can you tell a bit more about the apps that you've tried those new approaches?
Yeah. I mean, none of these apps they've all been for like personal use. So they're not like anything earth shattering. The most kind of complicated one is one I'm just actually finishing up. And my wife and I have been working on it. And it's like a kitchen AI. So basically, you can like take a photo of different ingredients in your kitchen, and then the AI will then sort of like convert those into ingredients in the store. And then you can set like, what is the fill level? When's the expiration date? And then when you want to go do a recipe, you can upload, like you can kind of copy and paste a recipe into it, and it kind of like parses out all of the ingredients. And then what's interesting is like, it's actually kind of like ingredient or recipes all kind of describe ingredients slightly differently. So like just doing like a naive matching or something, you won't actually work. But then, so I'm using like embeddings to kind of do more fuzzy semantic match between the ingredients in the kitchen and like the recipe ingredients. And so then I'll say like, hey, here's all the ingredients you have. Here's the ones you need to buy. But it'll also sort of like tell you, it's like, oh, hey, you're running low. You should double check if you have enough of this one. Or, oh, this one is like expired. So you should probably just get some new spice. So you're, because the old one doesn't taste very good anymore. Anyways, and then it's sort of a one click, create a shopping list with, we're using Trello. So just sort of like sends it off to Trello. Another cool thing that we did is like we just give it an enum of sections in the grocery store. So it's like there's meat and seafood and dairy and produce and canned goods and stuff. And so then each ingredient is coded to one of those sections. And so then when you go to the store, you have this like neat list of the different things. So it's actually pretty fun to use. It's pretty fun to build. But yeah, so the actual process of building it is, the local first stuff, the ElectricSQL stuff is defining my schema. Another cool thing about all this too is it's very data centric. I've noticed a big shift in how I build stuff now versus before is it used to be steady at the back end and like the database, everything was like annoyingly complicated that I just sort of delayed it until I was sort of more or less finished prototyping. So what I would do is like just keep all the data in memory in the browser and then build the UI, try a bunch of stuff, and just kind of like have a little JavaScript arrays and objects, and whatever. And then finally I was like, okay, now I kind of like know what my data structure is and everything. And now I'll just actually set up the database and start persisting it and whatever. But now it's like so easy with ElectricSQL to kind of set up the database and have a client and have everything syncing that like the very first thing I do is write my create table stuff and I have the tables, and which is a huge improvement because it's very nice having a fully typed database. I because you have all the Postgres stuff, so you can like pull up PSQL and start writing queries. And anyways, there's a lot of power you get for free, and you have like type checking, you have you know foreign key constraints. So you have kind of all these nice things that database give you from day one while you're just prototyping. Normally what I do when I'm prototyping is I just blowing away the database and restarting. But that again is like 30 seconds or something to do. It's also quite fun too. Like ChatGPT is like great at like creating SQL. So I use that a ton when I'm prototyping. I just sort of like just kind of freehand describe all the data I need, like and then it spits out, like 5 create table statements, and I just like pop it in and off I go. It's very, very productive, and it's quite fun just to have a full blown typed database backed, SQL first reactive system while you're prototyping. Yeah, it's both like a very productive prototyping system, but what's genius about, of course, about the whole thing is like your prototype that is immediately your production system too, because I can just like as soon as I'm done, like I don't have to like fix up a bunch of data problems because it's been good from the get go. I just ship it and it works perfectly, and I'm not like, oh no, I have all this like crap data now that's accumulated production system. I took all these shortcuts, to like work on my prototype. It's just you have all the database guarantees from the get go.
I love that story. I think this is so powerful. And the analogy you've provided before in terms of going from jQuery, where you have to do everything manually, to React freeing you up to no longer having to do all of this manually. Now that really makes sense to me, because now you could, like, you've mentioned a few of like the new like AI aspects of this, or that the app is an app just for you and your wife, and that's totally fine. Like, you're basically now freed up by so much data wrangling, or before you would need to like maybe set up a GraphQL endpoint, a REST endpoint, and you'd spend so much time just to have all the data moving stuff taken care of. And if that now just works in the same way as React automatically working and keeping your views up to date, and now if we elevate to the next level of Maslow's hierarchy of needs for app development, and we have the data automatically taken care of, now you can focus actually on what makes the app fun and unique. So that makes a lot of sense, and I love your anecdotes there, of that you don't no longer need to think about this is like, it's kind of like stage one, everything is crap in prototyping mode, and then at some point you need to make it real in production mode. But with React, you also don't really distinguish too much about like, oh, am I now writing this for production or for prototyping? You're just doing it right, and it's easy from the get-go. And if you get the same thing for data, that's super powerful. So I love that.
Yeah, that's probably a good analogy, is like how powerful, how good of quality is some part of your stack, is if the prototyping is the same as like production, like there's no difference. Just another random tool I've been using lately, like SST. I don't know if you've played with that, but they have sort of their live development Lambda function, and it's like killer because you develop against an actual Lambda, and they kind of like intercept the call to the Lambda function and send it to your like laptop. So you kind of have like debugging logs and everything, but your everything is actually running in the cloud, and it's like going to S3 buckets and everything. So it's like the development environment is the same as your production environment, which is like pretty hard to do otherwise. Going from dev to production with SST is like there is no difference. Like it's the same stack. The React, it's like if your components are good for development, they're going to be efficient in production. And yeah, with ElectricSQL, like if it works in dev, it's going to work in prod. So yeah, which is awesome.
That's great. I would love to hear a bit more about the details of how you've built this app. And particularly, you've mentioned that you design your tables and your schemas. And you've mentioned that you're using Postgres more for like a server aspect and SQLite for the client state. Do you design one schema and that applies to both Postgres and SQLite equally? Do you distinguish between those?
Yeah. You create the table in Postgres, and then they call it like electrifying it, and then their sort of sync engine then automatically sets up that table for you in SQLite, and also like does migrations and all the other like complicated bits. You can do local only tables, but I've never needed to. There could definitely be stuff that's sort of like very specific to a client. But generally speaking, like all the data, I just want synced all around. Because again, one of the cool things about all this is that your desktop, if you have a phone running the app and you have a desktop running the app, they're like always in sync. So it's kind of like you can pull out a phone and it's like got the data. In my mind, all data should be synced all the time.
So that kitchen app that you've been describing, that sounds super cool, but it sounded you've been building a few different local first apps to really give this a try and get started with that local first paradigm. So which other apps have you been building?
Yeah, another app that I was pretty pleased with, and I think is another good example of kind of the benefit of this like sync engine approach, is it's very simple. It's a one page, one view app, but basically it's like I use Garmin. I have a Garmin watch for like tracking exercise, like running, biking, etc. And they have a bunch of like charts and stuff that they kind of like pre-designed for you. But I was like, hey, I want to like look at it from a different way. Basically, I wanted a pure volume based view of my exercise. So because they like emphasize like intensity or mileage, and I'm just like I just care how long I'm running or how long I'm biking, etc. And so I was like, hey, they have an API. I'll just pull in the data, analyze it, create a chart, off off we go. So the cool thing about it is that so basically how the app works is like it's using ElectricSQL again, so it has all of your activities cached locally. So when you load it up, like it's instantaneous. It doesn't have to load a whole bunch of data off the server. It's just like boop, runs a quick SQL query, presents the charts and stuff. But then also when you load it though, it hits a Lambda function, which then syncs in any new activities from Garmin into the system. And what's fun about that is like just how simple it was, because all it does is it like hits the API and then writes out new data into Postgres, which is like, okay, that's fine. But then the next step, you're like, well, how do you like tell the front end that like the new data is done or whatever? There's like a bunch of other stuff. But what's great about it is like there is no other step, because the sync engine just was like, oh, there's like a new Garmin activity pushed into the database. I'm going to push it to the client because it's subscribed to it and it's active. And so it's just kind of like it just shows up. That's again, it's kind of an illustration of like you have this sync engine. It's not just like reactive in the client. Like there's a lot of like we talk a lot about like client reactivity, and like there's a lot of libraries that do that. But this is more like a global reactivity. Like the whole system is reactive. Like any change anywhere gets pushed to every other node that cares about that. And that's just like a really powerful leap forward, not just for the like client server, but like even like server. Like I've thought a lot about like microservices. Everyone's like, like one big problem with microservices, they get very chatty because they're always like, is there any, because it's the same problem. They're always like polling like, hey, any new updates, And then they're like, anytime they want to do something, they're like, oh wait, I gotta go get some data there, get some data there. But with a sync engine, it's like, well, no, like each microservice can just say like, this is the data I care about, and it has like a local SQLite database running that it can query against whenever it wants, and like every bit of data is like up to date within like a fraction of a second. That just like would dramatically speed up a lot of sort of microservices setup, and dramatically reduce the chattiness going on in between different services. So anyway, so I think there's a lot of global reactivity powered by sync engine.
Yeah, I love that analogy. I think this was really like what blew my mind about React in the like when I saw it the first time, not just that it made my life simpler by not having to take care of like all of the DOM children, like appending, creating, etc. So it made everything simpler, but also having all of that just work automatically without me having to even like tell it like, hey, now update that reactivity for the views, but also for like the local state, but applying that now for global data. I think that is really a killer feature of local first that I think is not well understood by a lot of app developers.
It's just so funny because like it's the water we live in, It's like, oh yeah, when you're building stuff, you spend a lot of time moving data around and checking it and updating it, and it's just like endless little problems. I remember like Gatsby Cloud, we would like it was such a common problem where it would like ship an update, which like used a slightly less efficient query or up the number of calls, internal API calls, and then all of a sudden, like our Postgres database would like redline, like, and we like, no, like revert or whatever, and like it was just like a constant headache because like when everyone's constantly like asking for stuff, there's just enormous inefficiencies. Because like I remember that was a big thing where people are like early on with React, people are like, oh, like my jQuery calls are so efficient, and like React is doing all this extra work and whatever. But what pretty soon everyone kind of realized is like, well, yes, like React does do extra work to accomplish the same goal, but it's only actually more work if every single jQuery operation was optimal. Like you'd actually thought through the algorithm, in detail for every single one. Because in practice, everyone was just doing lazy, weird shortcuts. You're like, I just got to ship this feature, so I'm just going to blow it away and rewrite the whole thing or whatever. We were doing all sorts of like weird, crappy things to kind of like update the DOM, which, yeah, it was just like very janky, very slow all the time, and whatever. So React was like, yeah, it's like there's some overhead to doing it automatically, but it was sort of like a consistent overhead, and everything was consistently a little bit slower than optimal instead of like sometimes optimal, sometimes wildly not optimal. And so the same thing with like moving data around. It's like, people are like, oh yeah, like my data fetching is so clean, it's so good. But you have one engineer who just accidentally grabs 5 megabytes of data from the API and like, whoops. And then all of a sudden, like the whole thing falls to pieces. Where again, with like sort of more of an higher level abstraction, it's like it just can't happen because you can like even put in checks. You're like, you can only ask for max of 300 kilobytes in a batch or something like that. Whatever. I mean, there's all sorts of like smarter things that the system can do for you. All kind of new abstractions that kind of like both face these same challenges or complaints. It's like, hey, like I do it really well and you're doing it poorly in all these cases and whatever. But if the abstraction is like good enough, it eventually pretty quickly becomes better in most cases and often better in all cases. And even if it's not better in all cases, like taken as a whole, it just eliminates a lot of really suboptimal problems. It's like memory management, that's sort of another great example. Like people are like, I manage memory so well, like these GCs, there's lots of overhead, blah, blah, blah. And then like 30 years of CVEs of, security issues. It is very, very hard to build fast, efficient data loading and keeping it up to date and whatever. After like, spending all this time building local first stuff, even like very good apps built with like great teams, like, name a name, like for sales dashboard. I mean, they're pushing like React server components and all that stuff. But like you click around their dashboard and there's like endless little like loading, like loading, 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 loading. If they had a sync engine, they would know that the next view has all the data and it's up to date. And they want to have to like go back to the server, like, hey, did anything change? Did anything change? Because I'm sure they have a local cache, but like what they're doing is always like asking again on every click. They're like, hey, has anything changed since the last time this person was here? And that like that request, like, or sort of that fundamental uncertainty with an imperative approach, like just because you can't know if the data is up to date. There's no way of knowing for sure because there's no system that's like reliably telling you that like, yes, the data is up to date for this next view. You have to check, and that check takes some amount of time, which adds glitchiness into your UI. And there's no way of getting away from that without a sync engine that can like provide the guarantee.
I think it's really interesting You've used the term thinking about your app data first, maybe as opposed to view first or React first. Yeah, I think that's kind of a big mental shift that I've also observed in my own app development evolution of my perspectives. And I think this has been a really powerful step because it intuitively makes sense that if you don't have the data, then if you want to render it and you don't have it, then you also can't render it. And so thus you render a loader or a skeleton, etc. Whereas if you think about your app navigation, routing, user experience overall more in a data first way to think about, okay, I'm currently here. This is all the data that I need, but also think a step ahead of like, oh, what if I would go to this other route here? Maybe I should already have the bare essentials in terms of the data for that. That if I'm going there, it's immediately available. And then you think about your data more. Maybe you think about it as a graph or like a collection of documents, however you want to think about the data, how it fits your app's use case. But once you start thinking about your app data first, I think it's so much easier to build a really high quality, fast user experience. Then, and it's also so much easier to make that available offline. I'm not sure whether you need Vercel's dashboard, which is gorgeous, but has a bunch of loading spinners. I don't think you need that necessarily to work offline. But another way to, if it works offline, then it's crazy fast. And I think it would be great if it was a lot faster. So I would completely agree with kind of thinking about your app development workflows as data first as opposed to React or Vue first. So we've been talking a lot about all the good things now that you've experienced with local first, but I'm sure you've also experienced like some pain points, some challenges in regards to that new approach of building software or in regards to the technologies you've been using. Tell me a bit about that. Which sort of challenges have you been experiencing here?
Yeah, there's definitely a few. I mean, there is some learning curve. It's not the same as what was before. There's a lot of things that cross over, so it's not like a huge step. You're gonna have to like spend some time learning stuff, regardless of the tool. Whatever tool you choose, you're gonna have to like learn stuff for that you don't know now. But I think there's also at this current point of immaturity in the market, there's not like a clear market leader who's very good and mature that lots of people use. So like in sort of app development, we're like, hey, Next.js, like that's sort of the obvious choice because a billion people use it and it's kind of covers everything and whatever. So you both have the I have to evaluate a bunch of tools step to get into this world, and then you're like, and then I have to learn a specific tool in depth because there's it's just different than like no one's done it before. Almost nobody's done it before, so you're gonna have to like learn stuff to do that. So that's definitely a bit of an overhead in this approach. Another result of the immaturity is like there's just things that don't work. So there's sort of the magical, like I've been kind of describing like thinking like, oh yeah, they're just sort of magic, but they're not actually magic. They actually are an engineered product, and there's stuff that they just don't do yet that you'd rather like them to do. And so it's learning those limitations and like working within them, or even decide if you can or not is part of sort of the evaluation process and building process. So far for my toy apps, it hasn't been an issue, but like there's definitely things that I'm like, I can't build those things with this stack right now. And like, yeah, the engineering, the teams behind these, like they know about it and like they're working hard to fix them. A lot of stuff is kind of like just the same. It's just building an app. You're just like, I need data and data's there. Before I'd write a REST API call or a GraphQL call or whatever. And on the back end, I'd write a query. And now you just write the same query, but it runs locally. And the day to day, just like building views and stuff, it's extremely similar. It's like before you'd probably like just sort of hash out like the data locally and the client. But now I just sort of like, oh, I need to like change my data model. So I'll just tweak the database structure a bit and then, change my query a bit in the front end. So yeah, I mean, day to day, it's like, it's very similar, but just like less steps because you don't have to like change your GraphQL or you don't have to change like the client call. It's only like two steps. It's like you change the database table and then you change your query in your component, and then that's about it. So it's pretty simple.
That makes a lot of sense. And I mean, this overall trade as for most early technologies. If you're early to those technologies, you bet on some superpowers and you probably acquire those new superpowers earlier than most others. but you also got to pay a higher price than most others.
Yeah, it's just like, yeah, I think the biggest thing is like I just randomly have gone into like, oh, I'm doing something, and then like, bam, I hit something, and then I'm like stalled for like a day while I either figure it out or figure out a workaround. So I think it's kind of like if you're using boring technology, it's like it may be tedious and hard or whatever, but it's sort of like a known tedium. You're like, this is going to take me like 1 week. Where with a new technology, it's either going to take you an hour or 2 weeks. So there's a lot more uncertainty on what's going to happen, and you might run into stuff that's just like absolute blockers. Where again, with the old stuff, it's kind of like every single possible workaround has been figured out for every possible thing. And so it's just a matter of finding that obscure forum post from like 5 years ago where they're like some weirdos like, oh, I spent 5 days on this, but here's the fix. And you're like, freak, like we have a kinship, you and I now. We two people are the only ones that ever run into this problem before. But thank you. You wrote it down for me, so I don't have to figure it out myself. So yeah, with the new technology, it's like most of the problems you run into, you are the very first person to run into it, which is fun. It's sort of like, yay, you're like, I don't know. But yeah, it's you're gonna have to be like a pioneer, sort of a more robust. I don't know if Europeans talk about pioneers, but anyways, like American pioneer, you're kind of like, we're going off into the wilderness and got an axe on our shoulder and whatever. We're just gonna like make it happen. You kind of have to adopt that mindset when you're kind of into new technology.
Yeah, that's very relatable for me. I've always considered myself to be kind of like a technical pioneer. So what you've just mentioned in terms of, yeah, sometimes like it's a gamble, and sometimes like it's the sort of promise of everything will be simpler and easier in the future that plays out, and you can't believe like how the thing that just took so much effort and so much work in the past is now so easy. Or you run into a wall where in theory it would have worked, but you run into some edge case that you're the first one running into. And it might be fixed with the next release of whatever you're using, but you still have run into it. But luckily, you've run into it, and then the next person is no longer running into it, depending on how quickly someone releases.
Yeah, there's sort of the sense of community service you get, or at least it's helpful to get with new technology because you're like, yeah, I'm going to pay down the cost for everyone else a bit.
So, another observation here, I think it's really interesting that the use cases you've mentioned, your ambitions for those apps were not to like take it to market and like roll it out to millions of users. It was, I think, like part of the fun that you build the software that's just for you, and you can make it as fancy or ugly as you want. Like no one's gonna complain, and like the little quirks of it, and that it took you less effort to make that happen, to build the thing you wanted to build, and like spend less time with like all of the boilerplatey things. That's great, and I think that is totally fine. Like no one's going to take that away from you. I think what's still a little bit less proven is like how do you really, if you were to take that app now and say I do want to scale it to millions of users, etc. I think that's another aspect of where we're still pretty early, and on our pioneering journey we have not yet figured out like hit all the traps. But I think from first principles, I think this approach should actually work out.
I don't see any like showstoppers for sort of scale to millions. In a lot of ways, again, too, it's like it's actually no apps do scale to a million. What happens is people build it and it falls apart, and then they like rebuild it several times and get to millions. So what actually I think is actually pretty interesting about this and like promising is like there is a story here, prototype to millions with like no changes to your basic architecture, which I don't think anything else can make that claim. But like the base system of like what everyone plans to do is like you can horizontally scale sync engines without any issues because you can just have sticky connections from clients to a particular sync engine, and it's managing the state for each user. Postgres is easy to vertically scale. What's interesting also is like Postgres actually has like a lot less demand in this world because far fewer queries are reaching it. So it's actually like you don't have to scale Postgres nearly as fast as you kind of typically would expect to. With this approach, people either do sort of normal API stuff because you can still just call Lambda and do whatever and write to Postgres. Kind of I was talking about the Garmin example. You can write locally like, I want to do this, sort of more sort of event sourcing style where you're like, the client says, I want this to happen, and then a backend serverless function picks up the job and then kind of writes it back, and then it gets synced back to the client. Anyway, so that again, that approach is also extremely scalable because it's all serverless and stateless, and you can have as many workers, spinning up to handle stuff for people. But yeah, we're not there. That's all very potential. But I think what's extremely promising is like, what are the different stages? What are the three major stages? It's like, how efficient is a tool at prototyping? How easy is to go from prototype to production? And then how easy is to scale? So those are like three distinct problems. So problem one, prototyping, I think both of our experiences, it's a lot easier to prototype with a stack. Like it's data centric. You have like a full type safe client, from the get go. A lot of boilerplate is gone. Like you just like bam, you go. And then again, like prototype production, extremely easy. I've done lots of side projects in the past that I always kind of came down to it. Now I'm gonna deploy it, and I was like, I have to rewrite so many things, and I have to like do all this crap that I didn't have to do before. Like, oh no, where's the state gonna go? Whatever. Like, I've gotten my sort of go live checklist. It's like 5 things, and like it takes me less than an hour. So it's extremely fast to go from like prototype to production. And then, production scaling. Yeah, that's the part that doesn't really exist. But in theory, like I think the architecture is like a very scale free, like it's mainly just the sync engine that needs proven at scale.
I mean, I do think that I fully agree with the way how you delineated that into those like 3 steps. But I would even say that the scaling part, I think, has been proven by quite a couple of companies by now, whether it's like thinking about Replicache. Rosy Corp has built with Replicache and Reflect, etc. I think they have a couple of customers that are really going at scale, and the entire system, I think, is quite inherently scalable, and it doesn't change the simplicity of the system, which is the beauty. And a lot of the parts of the system can still be considered stateless, which makes it a lot easier to reason about.
Linear had a really great talk about the Linear CTO had a really great talk about how they scaled their sync engine, and it's pretty fascinating, like all the things that they did. But yeah, to your point, people have gone down the path. So innovation kind of goes through like, is this thing even possible? Or like somebody has to like discover something. Like there's this new thing that we can do. Wow, who knew? And then it sort of like goes from that to then sort of eventually to sort of a product where it's kind of like that technology is then encapsulated to something that anybody can use. So the fact that multiple independent teams have successfully gone down this path shows that then sort of now what we're seeing is sort of a productization of sync engines. If you want to do a sync engine, you don't have to like buy it. You don't have to build it. You can just buy it off the shelf. I think we're pretty close to that being a reality.
So you've been going through this journey, I guess, over the last year or so of like learning about local first, then step by step building your own apps with local first. What would be your advice to an app developer who's curious about local first but has not yet taken their own first steps? What would be your advice to them?
I don't know. My general advice on any technology is just to dive right in. I mean, there's lots of stuff you can read about it. So by all means, like listen to cool podcast. There's lots of blog posts. Yeah, so there's definitely lots you can read and listen to and watch and stuff. But there's no better way to feel it, to understand it and to really feel it than just to like start building some stuff. All the different tools have starters and they're very approachable. They're not like particularly hard to use. And take a day or two and build something. Because yeah, it's really just like when you just see it syncing between tabs and you're just kind of like you really kind of have to feel whenever you're just like used to doing something, you just forget about it. We get numb to all the stuff we do. So you really just have to like to really feel the difference of local first. You just have to build something and then you're just like, where's all this stuff that you just sort of feel voids in your soul. You're like, where's all the missing stuff? Like where's all those things I normally do? And you're just kind of like, oh, they're just gone. And then like after you've done a few, you're kind of like, you just start to forget about it. It's like this bad, weird dream of like spending all that time on all those things that are now gone. But yeah, you can't really appreciate that until you've actually built something.
Let's see whether in 5 years from now we look back into the days where we haven't been building with local first, and we see it just crystal clear as that analogy you've given before with going from jQuery to React, and React freed us up from having to think about how to render the views in the correct way. And now we get the same thing for data. So this is beautiful.
No, yeah. Talking to younger developers, like sometimes I mention jQuery and I'm like, oh wait, they've probably don't even really know what jQuery is. And it's just a very weird feeling to be like, oh yeah, just jQuery thing. It was like this, and they're just like, yeah, okay, whatever. Like, yeah, it'd be really amazing if like APIs was the same thing. You're like, yeah, we used to like you'd write like an HTTP method, and then you sort of like make up a name that sort of meant something, and then you like had to like remember to like write it all the same thing in your client. You're like, it's not a post, it's a put, and then you have to like no typos, and they're like, that sounds like a lot of tedious, fragile, annoying code to write. And you're like, yeah, it was. It sucked. And they're like, I just used like the library and I just sort of type stuff, and like Copilot V10 just sort of like spits out whole stuff, because it just introspects in my whole data system and like writes out super efficient stuff for me. And yeah, I'm very big on like getting rid of work we don't have to do, and I think there's a lot left in programming that we really shouldn't have to do.
Let's leave it here. Anything you want to share with the audience?
Have fun, build cool stuff.
That sounds great. Kyle, thank you so much for coming on the podcast. This was a lot of fun.
Yeah, it was a lot of fun.
Thank you for listening to the Local First FM podcast. If you've enjoyed this episode and haven't done so already, please subscribe and leave a review wherever you're listening. Please also tell your friends about it if you think they could be interested in Local First. If you have feedback, questions, or ideas for the podcast, please get in touch via hello@localfirstfm or use the feedback form on our website. Special thanks to Expo and Crab Nebula for supporting this podcast. See you next time.